Okay, so inverse trig functions. In core 3 we learned that there was a particular attraction to being able to say that the inverse was a function. Now, we don't always have to be attracted to that. So I see nothing wrong with under the x squared business. I see nothing wrong with the number 2 and the number -2 both becoming the number 4, which means the back again relation would take the number 4 to the numbers 2 and -2, and I see nothing wrong with that. But often we're obsessed with the back again relation being a function, which means we can't have this business of the number 4 going back to 2 possibilities. We want to insist that it goes back to 1. And the device we used for that, so if y was x squared, then y being root x would do the job, because when you put the number 4 in that, what happens to it? It goes to just the number 2. Okay, because that's whoever invented the square root symbol, that was their decision, and they decided that the square root symbol would only have one answer. Okay, and part of the reason that was the obsession that we have for there being only one possibility for the back again rule, because we want to be able to say that the back again relation is a function. Now, that's exactly what happens in this trig business. Y equals sine x is about as many to one an example as it's possible to get, because there's so many values that go to the same thing. So pi over 2, what's the sign of that? 1, right? Am I right? Sine of 90 is 1. Should I convince you of that? Sine is just how high you are when you swing around the circle, so start there, swing around, you end up there. How high is that? 1. But what else has a sine of 1? 5 times 90, so swinging all the way around and then going 1 again. So what's that? Well, it's just 5 pi over 2, isn't it? That also goes to the number 1. -3 pi over 2. So in other words, start there, go 1 lot of 90, 2 lots of 90, 3 lots of 90. That goes to the number 1. And this is all reflected on the fact that the graph is a Loch Ness monster, which achieves the height of 1 millions of times. There, etc. Okay? So the back again relation is 1 to many, 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 many. Okay? But again, an obsession with having a 1 to having a inverse that was a function, we basically say that we're only going to start with values between pi over 2 and negative pi over 2 and pi over 2, which means we're now only looking at this part of the graph. So I'm going to try and draw this properly. I'm going to use 2 grid squares meaning the number 1, which means pi over 2 is 1.57-ish. So therefore it's a little bit more than 3 grid squares. So it goes like this. And that's it. It's the Loch Ness monster with all wide bits cut away, so it's just that. Okay? Now, that is 1 to 1 because horizontal lines only cut once. So therefore it's not many to 1. Also, vertical lines only ever cut once, so therefore it's not 1 to many, and therefore it's 1 to 1. Okay? Now the inverse of that is just a reflection in y equals x. So this is pi over 2 comma 1, so we're going to have a point which is 1 comma pi over 2. There it is. This is negative pi over 2 comma negative 1, so we're going to have a point which is negative 1 comma negative pi over 2, which is there. And so this fella here that I'm drawing That's the graph of the inverse. And it's 1 to 1 because the original function was. Okay? Now there's a special name for that fella. He's called arc sine x. So arc sine x is just a special word for the back again function for sine x. Okay, Mahumi, you cool with that?
Yeah.
Emma, you cool with that?
Yeah.
Sophie, you right?
Mm-hmm.
Nabia? You cool? Now, if you weren't so obsessed with the back again relation being a function, we could have continued the Loch Ness Monster out, and therefore it would have continued up when we reflected it, and therefore the original being many to one, the inverse would have been 1 to many. But that's just not the decision that's been taken over the years. So when you see that, you're talking about a tiny, tiny graph, a mere shell of the Loch Ness Monster that used to be. Okay, it's a tragic tale. Okay? Right, let's do it for y equals cos x. Now the Loch Ness Monster for cos x is this. Now, that is about as many to one as a function can get, so therefore when we reflect it in y equals x, it'll be about as 1 to many as a relation can get. So if we want to stop that, what can we do? Well, there's loads of options. The option that is famously taken is just this stretch here. Horizontal and vertical lines only ever cut this stretch once. So therefore it's 1 to 1. And when you reflect it, it'll still be 1 to 1. Okay, so I'll draw that properly. Just that little stretch. I'll get the scale right. It's pi over 2, a little bit more than 1.57. And that's pi, which is a little bit more than 3.